In this video, we'll talk about permutations. The formula for permutation is permutation of n taken k times equals n factorial over n minus k factorial. Another thing that is important is that order counts. So let's solve an example. Example 1 says finds permutation of 7 taken 3 times. So based on the formula, permutation of n taken k times equals n factorial over n minus k factorial, let's calculate permutation of 7 taken 3 times. So in this case, n it's 7 and k it's 3. So when we replace in the formula, we have 7 factorial over 7 minus 3 factorial. 7 factorial over, we have to do the parentheses first, so 4 factorial. Now factorial, 7 factorial means 1 times 2 times 3 times 4 times 5 times 6 times 7. And 4 factorial means 1 times 2 times 3 times 4. So we notice that 1 divided by 1 it's 1, 2 divided by 2 it's 1, 3 divided by 3 it's 1, 4 divided by 4 it's 1. So we end up with 5 times 6 times 7, which is 210. Another way we can solve this, we can say from 7 factorial over 4 factorial, we can say 7 factorial it's 7 times 6 times 5 times 4 times 3 times 2 times 1. So we write them in decreasing order, and then 4 times 3 times 2 times 1. These 3 cancel with these 3, and we still get 7 times 6 times 5, which is exactly 210. Multiplication is commutative, so I can write them in that way. But there is another way also. So from 7 factorial over 4 factorial, we also notice that 1 times 2 times 3 times 4, this product, it's actually 4 factorial. So in order to get 7 factorial, we still have to multiply times 5 times 6 times 7 over 4 factorial. 4 factorial divided by 4 factorial, it's 1. So we get 6 times 7, 5 times 6 times 7, which is 210. And we use the fact that we wrote the higher factorial using a lower value. So we 4 factorial and then whatever is left to get the 7 factorial. Example 2. How many ways can one choose one president, one vice president, and one secretary from 10 people if each position is to be held by only one person and no person can hold more than one office? So this part is the part where we say permutation because order counts, like if a person is president or vice president or secretary, it makes a difference because each position has different responsibilities. So order counts. There are 10 people in total, so permutation of 10 taken, and one president, one vice president, and one secretary means 3. So permutation of 10 taken 3 times, or sometimes it can be written like this, permutation of 10 taken 3 times. So based on the formula, it's 10 factorial over 10 minus 3 factorial. So we have 10 factorial over 7 factorial. 10 factorial can be written in terms of 7 factorial as 7 factorial times 8 times 9 times 10, because 7 factorial is the product of all the numbers up to 7. So I need to multiply 8 times 9 times 10 to get a 10 factorial over 7 factorial. Now 7 factorial divided by 7 factorial, it's 1. So we end up with 8 times 9 times 10, which is 720. Using the example 2, let's try to solve example 3. If the president, vice president, and secretary were chosen at random, what is the probability of any particular group of 3 would be chosen? So the probability, this P stands for permutation, but this P stands for probability. So the probability that three people, three specific people are chosen is given by the number of ways to get those particular people over the total number of possible outcomes. So, in this case, the total number of possible outcomes was calculating in example 2, because out of 10 people to choose this specific 3 positions, right, 1, 1, 1, that makes it a 3, it's given by permutation of 10 taken 3 times. So that is the denominator of 720. Now, if we want to choose 3 specific people like John, Mary, and George out of all those 10, only these specific ones, well, there is only one possibility to do that. So the probability is 1 over 720, which you can divide if you had to calculate using decimals. So 1 divided by 720 is 0.00139 if we were to round to 5 decimals. So here is the information about permutations and a few problems about it. So I do hope this helps.